All right, so let's take a look at example 1. Are they similar?
No.
So take a look at this. No, we're not really solving anything yet. Are they similar?
No.
Why? Okay, so Victoria, you said yes. Tell me why.
Because all of the second triangle's measurements are 3 times the other.
Yeah, so we look at the ratios of corresponding sides. 10 over 30 is equal to 20 or 7 over 21, which is equal to 15 over 45. Okay, so yeah, so we say yes, and then which one allows us to say that? That's side, side, side. Now, one of the things I want to ask you guys to do is write out a similarity statement. In a similarity statement, you're going to tell me which 2 triangles are similar. So we're going to say that triangle QPR is similar to, that's what that little teal name means, similar to what other triangle? NOM. And again, just like in triangle congruence, it's really important to get your corresponding parts to line up. By the way, what is so this is our statement. So when it says similarity statement, that's what it's talking about. What 2 shapes are similar. Well, what's my similarity ratio? Okay. Basically, when you think about the similarity ratio, you want to think the new over the old. And here in the United States, we read left to right. So which one's our new one? No, if we're reading left to right, which one's the new? The NOM. So basically, you're going to take one of the sides of NOM. So let's take NM over what? Now, what does NM correspond to? QR. Okay, what's the length of NM? 30 over 10, and we get 3. So I somewhat made that a little more complex. I know Victoria said right away, everything's being multiplied by 3, that's your similarity ratio. But it's not always going to be that obvious and that simple. So I want to make sure you guys understood how to set it up and find the similarity ratio. So again, we're always going to do the new over the old. All right, take a look at example 2. Are we similar? Well, that almost looks like which one of the theorems? Almost looks like side angle side. And the first thing we should check is the included angle the same? Okay, so we got the angle part. What does the 8 correspond to? 10. So there's 8 over 10. And we're going to ask ourselves, is that equal to, what does the 12 correspond to? 12 over 15. Well, what's 8 over 10 as a reduced fraction? 4/5. And what about 12/15? So are my sides proportional? Yes. So this is yes by side. Okay, so what's my similarity ratio? Or not my ratio, but my statement, my similarity statement. Okay? HG. Okay, similar to. Yes. Y, X, Z. Now, what about my similarity ratio? Well, what is, okay, we're going to do the new, so let's take 15. We're going to do 15 over what? 12. So what does that come out to be? multiply each one by 3, and we get
5/4.
5/4. So that's my similarity ratio of 5/4. Okay, example 3. Are my two triangles similar? What do you think, Alyssa? Why are they the same? All right, let me do something real quick here. Let's do this. Let's add a page. And we'll do some quick modeling. What can you tell me about these two triangles?
Exactly the same.
Exactly the same. So my sides are the same. And what about my angles?
Angles are the same.
Angles are also the same. Therefore, they are, what's that word? Congruent. But if I take this shape and I scale it down, what do you notice about my angles? Do my angles change?
No.
Well, what about my sides?
Yes.
So just because I had two angles that are the same, does that make my triangle congruent?
No.
No. But it does mean that they are
The same.
similar. So this is yes by side, or sorry, by angle. So remember, if you have two triangles that have two angles that are the same, then they are similar. They're not necessarily congruent. Is congruent the same thing as being similar? If you're congruent, are you similar? Why not?
Similarity is like your ratio on the same congruent is exact.
What would be your similarity ratio if you were congruent?
Similarity ratio.
You go 1 to 1, which means that all your sides are the same ratio, right?
Yes.
So yes, congruent is similar, which is the whole point behind the equal sign with the squiggly line. You're equal and similar. Okay, so that's why congruent is a really strong connection between two shapes. Okay, so when you're congruent, you're both equal and similar. You just have a similarity ratio of 1. Okay. All right. I thought I grabbed the eraser on that one. There we go. What about number 4?
Yes. No. Yes, no.
Why not?
Because, like, okay, their angles are the same,
Okay.
but in their X, Y, and HD are the same.
Uh-huh.
But FH, ZX, FG, oh hi.
Okay, so yeah, FG,
and ZH or
ZY.
or ZX is on the opposite sides.
Okay. Right, and when we're looking at this almost looks like the model for SAS, right? But again, to be SAS, it has to be the included angle. Well, we have our included angle here on FGH, but not on ZXY. So therefore, not similar.